Right, in this video we're having a look at these three particular lines, so some general equations of lines. Okay, and we've looked at them before and trying to work out what the gradient of those are and what the y-intercept of those are. So we should have seen in a previous video y equals mx plus c. Now the m here is the gradient, the slope of the line, and the c is the y-intercept, so y-int, I'm going to call it, so where the line cuts the y-axis. Now, if I look at this first one, I haven't got 1y, and I want 1y because there's 1y here. I've got 3y, so how do I get 1y down to 3y? Well, all I'm actually going to do is divide everything by 3, and so I end up with y equals, now 2 divided by 3 isn't that nice, is it? But with these, you can probably just leave it as a fraction and put the 3 at the denominator of the fraction. 6 divided by 3 is nice and easy, however, that's 2. So therefore, the gradient of this first one is 2/3, and the y-intercept is -2. Don't forget that negative in front of the 2 there. Now, if I look at the second one is, well, it's even worse, really, if I'm honest, because I've got the x on the same side as the y, and I've got the number there, that's fine, but I've also got 2y, so I'm going to have to do a couple of things here. I'm going to have to get rid of this 3x by taking it over the other side, or balancing it however you've been taught, basically. So I'm going to take 3x away from both sides, first of all, and I'm going to end up with 2y equals 12, take away 3x. All right, because I've got plus 3x over there, when it goes over the other side, I'll put that in a bracket just to make it quite clear that that's what I'm doing. I ought to have done that really with the other one, actually. So there we go. So what I'm doing is taking 3x away from both sides. It leaves just the 2y there and a -3x there. Now, I don't want 2y's, so I want just 1y. So how do I get rid of that 2? I divide by 2. And so I'm left with 1y, divide that bit by 2, divide that bit by 2, and I'm actually going to leave it as 3/2. You could put it as 1.5 if you like, totally up to you. And now we can work out what the gradient and the y-intercept are. So the gradient here, the gradient is the number in front of x, so -3/2, and the y-intercept, okay, is the number that's on its own, and that's 6. If there's no sign in front of it, presume it's a positive. Now the last one, a little bit trickier again because everything's on the same side. I've also got -y here, so what I'm going to do first of all is I'm going to take that over to the other side. So I'm going to actually add 2 y's onto both sides. Now what that does is the 5x doesn't change, it stays where it is. The -3 doesn't change, but this -2y goes over to the other side and becomes plus 2y. Now don't be put off by the fact that the y bit is on the right hand side of the fraction. That makes absolutely no difference whatsoever. Now again, I've got 2 y's, I don't want 2 y's, I want 1 y, so I'm going to divide everything by 2. 5/2x minus 3/2, oh, what did I, 5/2x, sorry, do apologise, 5/2x and 3/2 equals y. So now the number next to x, oops, oh, all my spelling's going pear-shaped now, is 5/2 or 2.5, it doesn't really matter, and the y-intercept is the number on its own, which is negative, don't forget the negative there, 3/2 or 1.5, doesn't really matter which.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.